All right, in this video, we're going to see what happens when we connect some of these flip-flops together in series. So I'll draw exactly what I mean by that. So let's say we have 3 flip-flops. Normally when I do this on a big chalkboard, I do 4 flip-flops, but we're a little space limited here. I might actually draw these smaller because we're so space limited. Okay, so I have some small flip-flops. While I'm drawing these flip-flops, like our other digital components, come on chips. You can buy, I think, 14-pin dips that have 2 flip-flops on them, if that's right. Something like that. So you can buy, little chips that have multiple flip-flops on them and wire them up however you'd like. Okay, so we have our J input, we have our K input, we have our clock input, we have our Q output, and we have our Q inverse output. So I'm going to label these flip-flops 0, 1, and 2. So we're starting our counting at 0. And in our inputs, all of our J's and all of our K's, we're going to put all of these to plus 5 volts, meaning that we are, those are on signals, right? So these are all plus 5 volts. And of course, from our truth table, we know that all of these flip-flops then are going to be in toggle mode. Okay, we're then going to take this output and take this and put this into the clock input of number 1. We're going to take the Q output of number 1 and put it to the clock input of number 2. And this is still a Q output. Okay, so we have Q0, Q1, and Q2. So those are our 3 outputs of our 3 flip-flops. And into our clock, we're going to put our square wave clock signal as we've seen before. Okay, so let's draw a timing diagram for what happens with this circuit. So here's our clock. I'm gonna add one more on this side. Okay, clock. So we need to figure out what's going on with Q0 and Q1 and Q2. Okay, so we'll say that all 3 of these start off. So they all start with values at 0. And it's not super important that that's the case. Our analysis will be the same regardless, but you'll see why I've chosen that when we get to the end of this. Okay, so we know nothing happens until we get this first falling clock pulse. And when that happens, this is going to cause this flip-flop to toggle, right? So this causes flip-flop 0 to go from off to on. And when this happens, that of course causes the clock at chip 1 to go from off to on. But that doesn't cause anything to happen, right? It only, our flip-flops only change state when the clock goes from on to off. So when this happens to flip-flop 1, nothing changes for flip-flop 1, and nothing changes for flip-flop 2 because it hasn't even felt a signal at the clock yet. So, easy enough so far. Now, when we get to this next clock falling pulse, that is going to toggle flip-flop 0 again. So this is going to toggle from on to off. And now, since this is the clock input to that flip-flop, when flip-flop 1 feels this falling clock edge, flip-flop 1 is going to toggle. It is going to turn on. And when that happens, flip-flop 2 still does nothing because it still is waiting for that falling clock edge. Okay, so let's just do the rest of Q. So Q0 is going to change state, Q0 is going to change state every time there's a falling clock edge, right? So this we can just kind of draw all of without too much thinking about it. So note here, before we do too much other analysis, if we put a square wave in as the clock, we get a square wave out as Q0, but that square wave is at half the frequency. So sometimes this is called like a frequency divider circuit, because you put in a clock signal at 1 kilohertz and you get out a square wave at 500 hertz, or something like that. It's oscillating, it's switching only half as often as the input clock signal. Anyway, that's just neither here nor there. Okay, Q1 is feeling this Q0 as its clock input. So it is going to toggle every time Q0 has this falling edge, like it did right here, and like it does again right here, and like it will again over here, and like it will again over here, and so on. Okay. Q2 is going to do nothing until it feels a falling edge at Q1, which means it is 0, 0, 0, 0, 0 until here, where it's going to turn on, and then it is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 until here, when it turns off. Okay, this is it. We are done with our timing diagram, and that is everything. So what the heck is going on? What is this circuit doing? So I'm going to draw some numbers in just to represent what these variables are doing, right? So Q0 is 0 here, 1 here, 0 here, 1 here. Q1 is 0 for both of these, 1 for both of these, 0 for both of these, 1 for both of these, and so on. Q2 is 0 for all of these, and 1 for all of these, and then 0 again. Okay, so you may have noticed a pattern, you may not have noticed a pattern, that's okay. What is going on here is our circuit is counting in binary, and we'll talk about what that means, but the variables that we have here, 0, 1, and 2, these are like the digits of a number that as time is going by, this number is counting up from 0 to 7, and then after we get to 7 and we try to count one more, we roll over back to 0, and that's because there are only 3 flip-flops, each with 2 possible states, which means just in math terms, there are 2 to the 3 different combinations of states we can have here. 2 to the 3 is 8. So including the 0, that lets us count up to 7 and then end up back at 0 again. So we're going to talk about how this binary number system works, but what we are doing here is we have made a counter. And in particular, this is a 3-bit counter. We'll learn about what bits are later on. That's 3 pieces of on-off information. And this particular counter is not a very good one. If you actually wanted to count, you would use a purpose-made circuit, because this one has some shortcomings. But at least conceptually, you can see how you can arrange a bunch of flip-flops to actually perform a very useful function, right? Counting things is one of the most important things that computers can do. So this, I think this is super cool. It's sad that you guys will not get to build this circuit, because it is very satisfying to watch the circuit count up when you first do it. But we have lots more to learn about counters. So yeah, in the next video, we're going to learn about binary numbers, number systems, and what how we translate these ones and zeros into what we recognize as numbers.